Riddle of the day. I've got a dress and a pair of shoes that altogether cost $100. If the dress is $99 more expensive than the shoes, how much are the shoes? You can pause here to figure it out, but if your first instinct is to say that the shoes are $1, you'd actually be wrong. If these were $1 and these were $99, that would make the dress $98 more expensive than the shoe. The key is that I didn't say the dress was $99. I said the dress was $99 more expensive than the shoe. The shoe would have to be 50 cents and the dress $99.50. Now you might ask, why would anybody ever express the price of a dress in such a way? Well, when was the last time you told a friend that you were 5 minutes away from them? You didn't tell them where you were. You told them where you were in relation to them. Sometimes a question of where you are is actually meaningless. For example, where is the moon is a meaningless question. All we know is where the moon is in relation to the earth. Now, these shoes aren't actually 50 cents, but they might as well be. They're kind of crap. Riddle of the day. What is the sum of all the whole numbers between 1 and 100? So 1 plus 2 plus 3 plus 4, all the way to 100. You might have heard of this before. It actually goes along with a very famous urban legend of the great mathematician Gauss, who was said to have been given this question by a teacher who just wanted to keep the kids quiet and busy for some time. But while the other kids were plugging away at their calculators, Gauss realized he could add them in whatever order he liked. So if you add 1 plus 100, that makes 101. 2 plus 99 makes 101. 3 plus 98 makes 101. And 50 plus 51 makes 101. You can do that with every number. You can find a matching pair. So you have 50 pairs, each of them summing up to 101. 50 times 101, and the answer is 5,050. Riddle of the day. Let's say I toss a fair coin 10 times in a row and it lands on heads every single time. What are the chances that the next coin toss will be heads? Well, the answer is 50%. That's because coin tosses are independent of each other. The chances of getting heads is 50% every single time. It doesn't matter what happened in the past. Coins don't somehow retain a memory of what happened to them before you flip them. This is called the Bernoulli trial. And another example is if a couple has 5 girl babies in a row, the chances of the next baby being a girl is still 50%. Although the key word here, of course, is that it's a fair coin. If I toss 100 heads in a row, it might be reasonable for you to ask to see the coin. Let's say I've got a buried treasure. I won't tell you where it is, but if you point at a spot on the map, I'll tell you how far off you are. How many guesses like this will it take for you to find the exact location of the treasure? Pause here to think about it for a bit. Well, it should only take you at most 3 guesses to find the treasure, and there can be 3 random guesses. Let's say your first guess is 100 meters off. Could be in this direction, could be in that direction, or any other spot on the circle. So make a second random guess, and let's say that's 50 meters off. It could be anywhere on this circle. But it also has to be on the first circle, so it's one of these 2 intersection points that are on both circles at the same time. Now make a third guess anywhere else on the map, and you'll get 1 point of intersection of all 3 circles, which is where the treasure is. To give you guys a really dark example of how math is often used for evil, this is how some gay people are tracked down and persecuted in countries where they're not welcome, because Grindr is an app that tells you how far away you are from someone. And while it might seem like that's not a lot of information, all it takes is 3 guesses to pinpoint an exact location. Math story time. In June of 2011, the U.S. reported a net increase of 18,000 new jobs. And in the same month, the state of Wisconsin reported a net increase of 9,500 new jobs. So it seems like over 50% of the new jobs created in the states all happened in Wisconsin. At least that's what the Republican State Party thought when they published a news release saying as much. Well, in the same month, California created 28,800 new jobs, and Texas 32,000. So was Texas responsible for 200% of the job growth in the states? So what's going on here? Well, the reason why the national net increase was only as small as 18,000 was because of all the states that reported a net loss, which would have brought the total number down. So while it's often said that numbers don't lie, in this case, they're at the very least incredibly misleading and don't tell the full picture. Riddle of the day. There's a wig you really want, but it costs $97. So you borrow $50 from your mom and $50 from your dad, so you have $100 in your pocket. You buy the wig, $3 in change, you give 1 to your mom, 1 to your dad, and you keep $1 for yourself. Now you owe them each $49, but that adds up to $98, plus the dollar in your pocket is $99. So where'd the missing dollar go? Pause here to figure it out. Well, this is a trick question. There is no missing dollar. You owe them $98 in total, and you have $1 in your pocket. That should go against your debt. You owe them $97 in total, which is exactly the cost of the wig. To see how preposterous of a scenario this is, let's say you don't buy the wig at all. Let's say you keep the entire $100. Then you owe them each $50, so you owe them $100 plus $100 in your pocket, $200. Where did that come from? Just because you can add numbers together doesn't mean you should, and doesn't mean it means anything when you do. Here's a math riddle for you. When I was 13 years old, my mom was thrice my age. How old will I be when she's twice my age? Pause here to figure it out. All right, so the key to figuring out these types of questions is to find out the number of years in the age difference. So when I was 13, she'll have been 39, meaning there's an age difference of 26 years between us that will never change. So even when she's twice my age, she'll still be 26 years older than me. So if I were to make a line that's as long as her age, my age would be smack dab in the middle. But the difference between me and her would still be 26. But given that I'm smack dab in the middle, the other half of that line also has to be 26, meaning I'll be 26 years old and she'll be 52. However, that has not happened yet. Happy birthday, Mom. So you've probably heard before that it's impossible to fold a sheet of paper in half more than like 7 or 8 times. So here's one fold. Fold number 2, 3, 4, 5, and 6. And I can't do any more than this. Now let's say I was physically capable of folding this 42 times. How thick would this get? Would you believe me if I told you that the thickness would actually go from the Earth to the moon? Well, let's rewind a bit. When I folded this in half once, it was the thickness of 2 sheets of paper. Twice, and it was the thickness of 4 sheets of paper. 3 times, it would be the thickness of 8 sheets of paper, which is 2 to the power of 3. And every time you fold it, its thickness doubles, so the powers of 2 make sense. So folding it in half 42 times would get you the thickness of 2 to the power of 42 sheets of paper, which is over 4 trillion. Let's say the thickness of an average sheet of paper is just 1/10 of a millimeter. Multiply that by 4 trillion and convert to kilometers, you actually overshoot the moon. And that's on exponential growth. Whew, riddle of the day. Let's say I've got 2 thermometers. Let's just pretend, okay? This one works in Celsius and this one works in Fahrenheit. Is it true or false that the number of degrees in Celsius will always be lower than the number of degrees in Fahrenheit? If not, at what point will the number of degrees in Fahrenheit be a lower number? Pause here and think about it. So the answer is false. It's true for most of the temperatures we encounter on a daily basis. For example, 32 degrees Fahrenheit is the same as 0 degrees Celsius. 100 degrees Fahrenheit is the same as 38 degrees Celsius. However, the conversion between Celsius and Fahrenheit actually follows a very simple equation. And if you plot it on the same graph as the function f equals c, you'll notice that there is a point where they intersect. That's right, minus 40 degrees Fahrenheit is the exact same temperature as minus 40 degrees Celsius. So at that temperature, these 2 thermometers would actually say the exact same number. And anything colder than that, and the degrees in Fahrenheit would actually be lower. And if you live in Canada, not as rare as you might think. Riddle of the day. Let's say I've got 3 doors for you to choose from, and behind one of them is a brand new car, and behind the other 2 are goats. You choose a door. Let's say you choose this one. Before opening it, I will open a different door and reveal a goat behind it, and then offer you the chance to switch to the only other unopened door. Should you switch, stay, or does it even make a difference? Pause here and think about it. So the answer is to always switch. This is the famous Monty Hall problem. If you stay, your chances of winning the car are 33% or 1 in 3. But if you switch, those chances actually rise to 67%. That's because everybody who starts off with a goat and switches will always switch to a car because I removed the other goat from the game. And so the chances of winning a car under the switch strategy is the same as the chances of your first choice having been one of the 2 goat doors, which is 2 and 3. Unless, of course, you would prefer to go home with a goat, in which case, stay put. Hey, different strokes. Today's riddle of the day is one that sort of broke math. Say that there's a barber who shaves all and only those who don't shave themselves. Does the barber shave himself? Pause here and think about it. If the answer is yes, he does, then by his own rules, he can shave himself. But if he doesn't shave himself, then he must shave himself. This is an example of Russell's paradox, and it doesn't really have an answer, other than that such a barber can't exist. Before Russell came along, mathematicians defined a set as just any collection of things, which was exactly as vague as it sounds. It could be 0 things, infinite things, people, colors, sets within sets. But Russell came along and thought of a simple example of a set whose very existence was a logical paradox. So mathematicians had to rewrite the definitions and set some rules on what we mean when we say collection of things. Like a storm forces the spiders to reconstruct their spider webs, Russell's paradox forced mathematicians to reevaluate and reconstruct some of the most foundational ideas in the web of mathematics. Here's why it's impossible to draw this shape without overlapping the same line or having your pencil leave the paper. In graph theory, this type of problem is called an Euler walk. So first, let's define some terminology. The dots are going to be called nodes and the lines edges, and the number of edges that are connected to any node is called that node's degree. So let's label the degree of every node on this shape. Every time your pencil visits a node, it has to leave from a different edge it came in on. And if you end at the same place you started, you'll have left and returned on 2 different edges. So every node must be attached to an even number of edges, or in other words, it has to have an even degree. However, it's not against the rules to end at a different node than you started at, so it would be possible to leave the starting node and never return, and end at the ending node and never leave. So in this case, you'd need two nodes with odd degrees, which would be your start and end points. But this graph doesn't fit either of those criteria, and so it's impossible. And so are all of these. But these variations are possible. Oh, hi. Ever wonder why it always seems like the hot people are always such jerks? This is Jordan Ellenberg's example of Bergson's fallacy. Suppose that we could rank everyone on a scale of looks and personality. Here are the people who are really nice and pretty, mean and ugly, nice and ugly. You get the point. This adage that hot people have bad personalities often comes from dating experience. But think of the types of people that you date. You might put up with someone who's a little less attractive if they're funny and nice, and you might also put up with someone who's a little boring if you find them really hot. But if somebody's both mean and ugly, you won't even want to get to know them. They won't even be on your radar. And so all the people in this corner are out of sight and out of mind, and you claim that there's a negative correlation between looks and personality. But that's only because your dating experience is limited to the people in this subgroup of the population. Why does it seem like books are always better than the movies? Well, if a story made for a bad book and a bad movie, then it's probably so bad that you've never even heard of it. Riddle of the day. Linda is 31 years old. She's single, outspoken, a philosophy major, and she's deeply concerned with social justice and is anti-war. Which do you think is more probable? That Linda is a bank teller, or that Linda is a bank teller who is also a feminist? Pause here and think about it. Most people answer with number 2 because it sounds more like the description given of her, but this would actually be false. Think of a Venn diagram of all bank tellers and all feminists. If Linda indeed was a feminist bank teller, then she would fall into this intersection, which would already make her a bank teller. But on the off chance that she's not a feminist, she could still be a bank teller. The probability of being any kind of bank teller is higher than the probability of being one specific kind of bank teller. This is an example of conjunction fallacy, where we think that a more specific set of circumstances is more likely than the general set of circumstances. For example, drawing a red card from this deck is more likely than drawing a red card which also happens to be an ace, even if I tell you that the deck is filled with extra aces. Math story time. Let me set the scene. It's World War II and the American government is calling on you. A bunch of fighter planes have just come back from battle covered in bullet holes, and they want to know where is the best place to put armor on the planes. You can't put it everywhere because that would weigh down the planes, so you have to put it where the planes are most vulnerable. Bullet holes are scattered pretty much everywhere, but the spot with the fewest is the engine. So the Jewish mathematician Abraham Wald said, don't put armor where the bullet holes are. Put it where they're not, because the planes that got shot in the engine never survived to make it back. You might think that the spot with the most bullet holes is the most vulnerable, but this would be an example of survivorship bias, where you focus on only the things that survived some selection process and fail to consider those that didn't. Why was Wald able to see what experienced officers and trained pilots couldn't? Well, it's because mathematicians are always asking, is the sample representative of my population? And what assumptions am I making, and are they valid? Statistics is like a bikini. What it reveals is interesting, what it hides is crucial. If you've ever been approached to be part of a company whose main source of revenue is hiring new recruits that have to pay to get in, run the other way. Here's the math on why pyramid schemes and MLMs are a bad idea. Let's say the only way you can recover your investment is by hiring 3 new people, who each hire 3 new people, who each hire 3 new people. And as you can see, this grows exponentially by a factor of 3. And we can code this in a spreadsheet by writing equals the top box times 3 and drag down, and this number quickly grows. And as you can see, it only takes 23 stages of growth before everyone on the planet is signed up as a salesperson. And there's nobody left to recruit, no more money to be made, and most of these people are at the bottom of the pyramid. 99% of people who join MLMs lose money. If you have to pay to get in, I'm sorry to break it to you, you're not an employee, you're a customer. You know, a teacher of mine once presented our class with a problem that, in his opinion, broke the rules of math. So you start off with 1/3, which is 0.3 repeating. Multiply it by 3, you get 0.9 repeating. But 3/3 is 1, which in his opinion were 2 different numbers, and that was a contradiction. And certainly they look like 2 different numbers, but it wasn't until much later that I realized they are in fact the same. If they were different, I should be able to find a number in between 0.9 repeating and 1, but I can't. Think of 1 minus 0.9 repeating. That's 0.0 repeating. There's no 1 at the end of that, it's just 0. There's more than one way to write the same number. For instance, the number that we call 5 is the same as 2 plus 3, 10 divided by 2, 4.9 repeating, 6 minus 0.9 repeating. If you're familiar with infinite sums, you can also view 0.9 repeating as 9s multiplied by negative powers of 10. But again, this just sums up to 1. If it's any consolation, math would actually be a lot more confusing and a lot more broken if 0.9 repeating did not equal 1. Let's say you're ordering a pizza and you're about to get the large 18-inch pizza when you realize that for the same price, you can get 2 medium 12-inch pizzas. That's a better deal, right? Not at all. So the area of a circle is pi r squared. In this case, 18 and 12 are diameters. So we have to half them to get the radii 9 and 6. So the area of the large pizza would be 9 squared times pi, or 81 pi, and the medium 36 pi. So two mediums would thus have a combined area of 72 pi, which is a smaller area, meaning less pizza. But Kyne, 12 times 2 is 24, which is larger than 18. But we really shouldn't compare the diameters this way, because the area is really what tells you how much pizza you're getting. And the area formula squares the radius, so a couple of inches difference in the radius or diameter translates to a much larger difference in area because of how it gets squared. In most cases, but not all, the largest pizza is almost always the best deal.